Very good morning. Today we are going to see the topic data analytics and machine learning for chemical engineers. This is the title of the subject itself. I'm not getting into the syllabus. What I'm planning is that why we need to study this subject. That's what I'm going to discuss in today's topic. So data analytics and machine learning for chemical engineers is a need of the hour to learn as the people are moving towards artificial intelligence. So the backbone of artificial intelligence is machine learning is the backbone. Okay, we're supposed to learn, understand the machine learning process as well as the deep learning. Data analytics in chemical engineering involves systematic analysis of data generated from chemical processes to optimize efficiency. So first of all, we're supposed to know the process. Since you have been studying the chemical process industries, how the raw material has been converted into product. So obviously for the conversion of raw material into product, we need the unit operation and unit processes. As you know, the unit operation is a separation phenomena where only the physical transformation takes place, where the unit processes both physical as well as chemical transformation takes place. During these processes, there is a large quantity of data that may be collected in order to find out the optimized point so that we can get a optimized yield in terms of efficiency. What I mean is that yield is efficiency and improved product quality. There are some parameters which will give you a consistent product quality, and some parameters will change that will give you a better quality, and as well as at the same time we also need to look into the safety aspect. So this data, by analyzing this data, we supposed to optimize the process, improve the quality of the product, and also enhance the safety aspect as well. So this interdisciplinary approach integrates mathematical modeling, statistics, and machine learning with the core chemical engineering principles to make the data driven decisions. So how to the machine learning will helps us to analyze the data and try to give an output, okay, as per our needs. Okay, let's say imagine a cricket player is playing, a cricket player is facing the ball from the bowler, and he is coming out with this speed, and the spinning of the ball is the turning up of the spin is in this direction. Okay, so let's say we are collecting the particular data. So when a person, especially that particular spinner or a fast bowler, is coming at this speed and having this turning and turning direction, okay. So what is the how how the ball will be turned up, okay, to the stem, okay, can be predicted. Okay, so similarly here by collecting a lot of information and giving to the system, that will help us to analyze the data. Okay, so that is why this subject is very very important. Traditionally, chemical engineers relied on experimental data and theoretical models, but with advancements in computing and data science, engineers can now analyze vast amount of data in real time to predict the outcomes, detect anomalies, and enhance process control. So what do you mean by anomalies? Is a data point or pattern that deviates significantly from the normal. So detect anomalies is the differences, okay, the prediction pattern. For example, I can give a prediction pattern in a different scenario. Please imagine the people have been broadcasting the weather condition. So using during summer or winter, so obviously you know during winter the rain prediction may be usually given by the weather meteorology department, weather forecasting. So the people have been studying a large quantity of data for 50 years or 60 years during that period. How much is the amount of rainfall during that monsoon, or maybe whether there is a chances of rainfall on the next day or something. So detect anomalies if this pattern is deviates. Okay, so that's why they say anomaly refer to the data point or pattern that deviates significantly from the normal or expected behavior in the data set. So by seeing the data, analyzing the data, we should know. So this particular data is different from the data which is obtained altogether. So what is the average? So what is the why we need to study all this in perspective? Because the ultimate aim, by seeing the collecting a lot of data, and we could be able to predict the behavior of the data. That is very important. So once you predict the behavior of the data, that will help us to estimate the outcomes, predict the outcomes. Okay, and enhances the process control. So when you, for example, in process control as the level controller, let's say the level has been increased above the marginal height of the column. So let's say is a water tank filled with a certain level, and the level of the tank supposed to be maintained during the process is only 50% of the height of the column or height of the tank. Okay, so in that case, if it is more than 60%, more than 55%, or increasing more than 50%, especially 50%, and if it is say for 55 or 60, obviously what we'll do, we will try to reduce the flow so that the level of the tank will be reduced, right? So similarly, when we have collect this particular amount of particular data, that will help us to understand the behavior, okay, and also enhance the process control. That is the main thing here. Okay, why we need to study the data analytics and machine learning for chemical engineers? We'll study actually why we need to study the data analytics first. Okay, process optimization and efficiency, the first point, very important. So for all the process, all the chemical process, what we do, even from the starting of soap manufacturing, or you want to produce bulk chemicals, okay. So even the petroleum refining industries, what they do, they will try to optimize the process. So the energy consumption is supposed to be low. At the same time, the product separation or the production of product is supposed to be high. Data analytics helps identify inefficiencies in chemical processes, leading to reduce the waste and improve the yield. So when you have a predict the data, we have a large amount of data, and we understand the behavior of the system based on the data, so that we what we want positive, okay, positive output, and what we want in a lesser quantity, like pollution, reduced wastewater, okay, and improved yield is a positive thing. Example, analyzing the real-time sensor data in a distillation column to optimize energy consumption and maximize product quality. In a real-time sensor data in a distillation column. What is distillation column? That you know already. This is a separation phenomena where, because of the energy approach, okay, where we need to supply the energy in order to separate the component based on the boiling point difference, or we used to say is a correct term is vapor pressure difference. Let's say you have a binary distillation column. Okay, let you want to reduce, separate the two component A and B. By supplying the energy, just separate the two component A and B because of the boiling point, or you can see vapor pressure difference. So the sensor data in the distillation column to optimize the energy consumption. So at what temperature, what energy is supposed to be needed to the system in order to separate the two component. Okay, I'm not talking about here CO2 picture. I just talking about a given example for a binary um, separation phenomena. Okay, in a distillation column, and maximize the product purity. Okay, so next one is quality control and assurance. Ensures consistency in production by detecting deviation in product specifications. So because of collecting the data, it will ensure the consistency in production by detecting the deviation in product specification. Let's say I want the temperature and pressure supposed to be constant in a process. If it deviates, obviously the product yield will vary. The product yield variation will reduce my thing, as well as the quality of the product also may vary. So the consistency in production by detecting the deviation in the product specification. That is the thing. Using machine learning to predict the product defects in polymer manufacturing based on historical data. So for data analytics, especially to here what we are talking is in terms of output. So process variables variation or any other data which need to be varied actually. Okay. So how this affects the system? So ensure consistency in production by detecting the deviation in product specification. Okay. Then we'll go to the next one, predictive maintenance. So usually predictive maintenance, before in hand, we need to do that one, prevent equipment failure by predicting the when maintenance is needed. Okay, I can give an example for this. Let's say in day-to-day life, we have if you are using a bike or car, so you just see, check the tire, and the tire, because of the wear and tear, and it has been torn out, or it has been what you call it, become old. Obviously we say actually this need to be replaced by new tires. Okay, so like that, preventing prevents equipment failures by predicting when maintenance is needed. Okay, example, monitoring temperature and pressure variation in heat exchangers. Let's say in heat exchangers, the temperature and pressure are the important factors, especially the temperature is a heat transfer principles, and pressure variation in heat exchangers to predict the potential failure before they occur. Let's say, so the predictive maintenance is one of the parameters that is supposed to be uh, need to be taken care of. Another one is environmental and safety compliance, reduce emission and ensure adherence to environmental regulations. So because of this, collecting data and try to find out the reduce the emission and ensure adherence to environmental regulation, whether this system is as per the regulation norms. Otherwise what will happen, there's the chances of making the process, they may stop the process. Okay, so the regulation we need to follow. Okay, in India we have Tamil Nadu Pollution Control Board, Ministry of Environment, Forest, and Central Pollution under which the Central Pollution Control Board comes into picture. Okay, if you want to put a plant in abroad or a thing, you need to follow as per their regulations. Um, and most of the companies, they are trying to follow the USDPA standard. It's a very stringent laws. Okay, so what is necessity of all doing this thing is that MNCs. What I'm trying to say, the USDPA laws, MNCs, multinational companies, or even the companies, um, especially the companies which are inside the US, supposed to follow the USDPA standards. An example, using data analytics to monitor pollutant levels in wastewater treatment plant. That is an example. Okay, cost reduction and resource management. So because of studying the data analytics and try to predict the pattern, these are the advantages. What I'm saying is the all advantages: cost reduction and resource management, decision making and risk management. This is all what you call advantages. So they have given example explicitly analyzing the production data in a fertilizer plant to adjust the feedstock ratio and reduce the operational cost. So the ultimate aim of any industries, we need to produce the product at a low cost so that they can sell it at a very high profit margin or at a better cost when compared to the competitors cost for the same product, cost of the same product. So we need to be very careful in processing the raw material into product. So during this process, we have installation cost, operating cost, maintenance cost, labor cost. Okay, all this all involves. Try to minimize the process cost. So for which we need to optimize the process. So when we need to optimize the process, we need to know where to reduce it. Okay. So when the data is deviating from the product quality, it's a less product quality, or where we are lagging. So this data information will help us. Machine has been trained. Okay, the system has been trained and will give you a better output actually, and give you a better analysis regarding the thing. So that's the advantage of having a machine learning. Research and innovation. So how can I be advantage of, okay, fine. You may ask question, okay, if it is a process, so we understand because of the process variable change, obviously the output will change. So when we have a data, large amount of data, we could able to optimize the process and try to predict the thing which is going away from the cost cut or optimization. Okay, so when you have in terms of new technology, research and innovation, how this machine learning will help us accelerate new material discovery and formulation development. Okay, here again AI-based modeling is there to predict the properties of new catalysts for suitable chemical reactions. So nowadays it not need not be necessary to run the process and try to optimize it. Some 30, 40 years back, the people, in order to understand the process, they need to run the real lab scale study, and then they need to make it into a industrial scale, and later in fact they want to make it into what you call them, and they need to go for a production industrial scale, and then they'll do it. Okay, nowadays no need to go for even for lab scale. If the system is feasible and they find it out, they can direct, even for feasibility study they can go and study in terms of the mm, modeling techniques. So you already studied actually the process modeling and simulation lab, where uh, without actually there is a static simulation and dynamic simulation, Aspen Plus and Aspen ISIS, where we have studied actually how to understand the find it out the optimized point actually, and try to go for a rating method, rating model, or a design model. Okay, so what I'm trying to say is that applying AI-based modeling to predict the properties of new catalysts for suitable chemical reactions. AI-based modeling refers to the application of artificial intelligence techniques such as machine learning and deep learning. Very important point. So the AI-based modeling refers to the application of artificial intelligence techniques such as machine learning and deep learning to develop a predictive models for complex chemical engineering processes. So all I can say actually all the chemical engineering process is very complex in nature to solve the things, because it needs actually what you call um, very complex equation mathematical models, okay, to find out the pretty output efficiency or a product. So that's why the dimensions numbers are helpful for us, and which parameters are more dominant, whether it's may be a mass dominant, mass transfer dominant, or reaction rate dominant, okay, and things like that. So that will help us to reduce the complexity. So what they are saying is that artificial intelligence techniques such as machine learning to develop predictive models for complex model engineering process. These models analyze the historical and real-time data to optimize the operation, improve efficiency, and enhance decision making. So obviously, when we when we go for this type of models, will help us to optimize the process. Do the what you call make this process very simple. Okay, these models analyze the historical and real-time data to optimize the operation, improve efficiency, and enhance decision making. So, what is my conclusion on today's topic is that data analytics is a revolution in chemical engineering by making process smarter, safer, and more efficient. So the prediction of data, the analysis of data is very important. Okay, very important, and safer and more efficient. By studying this subject, engineers gain the skills to analyze the large data sets, extract meaningful insights, and apply them to a real-world chemical engineering process, ultimately driving innovation and sustainability in the industry. What they mean is that by studying the subject, the student can able to analyze the large data set. So what is the necessity, how to make use of the machine learning and deep learning, and try to find out the output, they extract meaningful insights and apply them to a real world chemical engineering process, ultimately driving the innovation and sustainability. So the thing is that so that we can go for any other methods is needed. Okay, so let's say any alternative method for doing the same final output. The innovation maybe comes out by studying it very elaborately on the data analytics thing. Okay, and then sustainability. So obviously we are just talking about in terms of the product output, as well as the reduction of wastewater generation or any environmental effect. Okay, at a low cost, and the cost also supposed to be less, and the process is a sustainable process, or the process, yeah, sustainable process as well as the optimized process. So with this, I just stop it here for today's subtopic. Okay, the subtopic here, what I mean is that we are just saying what is the necessity of studying this module, introduction to data analytics and machine learning for chemical engineers. With this note, I stop it here. See you in next video. Thank you.